Hey everybody, welcome to a minute of Cloudy with a Chance of Learning. It's meteorologist Meagan Massey's favorite day.
Yeah, so I love space, and we'll be talking about solar system part 3 today. We are going to finish all of the planets.
Yeah, the rest of them, the rest that are out there, way out there, well past the solar system. So we're going to finish up to talk about those today.
So we have Addison joining us from Converse. Hey Addison, glad that you're this Monday. I hope your day is going well, and I hope your week is starting off great. We also have Margie Bridges joining us, Brianna White. Hello, watching with my 3 and my 1-year-old. Hey, happy to have you guys here.
Camden and Kaysen, I hope y'all are having a wonderful day.
Yeah, and so we'll be talking about a lot. We're going to finish all of the solar system. Of course, we started out with the sun, which happens to be a star, right? So that's the first thing we started out with.
And then we continued on to talk about Mercury, Venus, and Earth, and then Mars, Jupiter, Saturn, and then beyond those, we have,
drum roll, we have Uranus, Neptune, and Pluto. So those are the 3 we'll be talking about. Now, I know Pluto is now considered a dwarf planet, but we are going to cover Pluto today. So what's your favorite planet? It's Jupiter, right?
Jupiter. Yeah, I love the big red spot, that big storm system, which, by the way, NASA just released some new photos of that.
Ooh.
They actually got some new photos of Jupiter. They released them recently. I think it was within the past week, and they posted them to their Facebook. Pretty cool stuff.
We also have Emily from first grade watching. Hey, Emily, glad that you're here. Ainsley saying hello. Hey, Ainsley, glad that you're here. And then Michael Sinclair saying hello there, y'all. So, hey, Michael, glad that you're here.
And hey, Matthew is in from Cibolo. You know, Meagan, Matthew, on Friday, I meant to show it to you. I will be sure to show her the photo, Matthew. He sent in a drawing of the solar system.
Sweet. Yes, I have to see that.
And we shared it for Fun Time Friday. Great job, Matthew. It was a great drawing, and thank you so much for sending it in to us.
And I'm curious to know, once we go through Pluto, what your favorite planet was. And it can also be the sun, as the star is one of your favorites that we've kind of covered with the solar system. Now, we've talked about how we're on part 3, but we'll be continuing part 4 of the solar system next Monday. That's when we'll be covering, you know, the rocky stuff in space. So we'll be covering, you know, the Milky Way. We'll be covering
comets and asteroids. There's an asteroid belt that sits just beyond Mars. It's a long distance between Mars and Jupiter. And between those two areas, there's an asteroid belt. So we're going to talk about that. It's some things that are just out of this world.
Yeah, there you go. There's that little pun there. All right, so let's go ahead and get started. We are starting out with, of course, the funny planet with a funny name. So get all the laughs out right now. You know, Uranus happens to be the 3rd largest diameter. So it is one of the largest planets in our solar system. Yeah,
it's a huge planet, and it actually even has 13 faint rings.
It does have 13 faint rings.
And Uranus is kind of unique because the rings aren't necessarily right there. You know, when we look at Saturn, the rings are right there, kind of at the equator, kind of like right at the center. Uranus, I guess it is at the equator too, but Uranus, they're like vertical. They're like this instead of like this across the planet.
Yeah. And actually Uranus happens to rotate backwards, but on its side. And there's another planet in our solar system that we talked about a couple of weeks ago, or a week ago, about another planet that rotates backwards. So comment which other planet you think rotates backwards. So this is also the first planet that was found by telescope by William Herschel. This was back in 1781. So years and years ago, 1781. That's incredible.
Yeah. And so they were still able to find all this stuff even way back then. When technology wasn't as good, they were able to figure this stuff out. Some really great scientific pioneers.
So Matthew pointed out how something seems a little different about you. I think it's the haircut.
I think it is. Got a haircut, finally. You know, a lot of us have finally gotten some haircuts. I know a lot of people have been running to the barbershops and salons to get haircuts.
Crystal says, hi from JJ. My favorite planet is Jupiter. So JJ also loves Jupiter, just like you, Andrew.
Nice. Yeah, my favorite as well.
Let's continue here. So like we said, this planet is 4 times wider than Earth.
And it rotates backwards and on its side. We talked about how the Earth rotates like this. Uranus rotates like this. And its rings are vertical like this. So you can't really see it in this photo, but they're there. It's really kind of interesting stuff.
One full day, you know how one full day for us is 24 hours. Well, one full day on the planet Uranus is 17 hours. And it takes about 30,687 Earth days to complete one orbit around the sun.
Ooh, that's a long
1 year
way away.
Yeah.
That's a long time. Could you imagine 30,687 Earth days? How many?
Time would go by slow, I guess.
Yeah, that would be really. You know, imagine you turn 1 year old.
Yeah.
On the planet Uranus.
I don't know how the math would work there on what that would be like in comparison to Earth days.
From now on, I only celebrate my birthday on Uranus years. Yeah.
So Brianna White says, my dad bought a $600 telescope a while back. We saw Saturn's rings and its moons. I think it was Saturn. We saw 3 moons beside it. That's incredible.
That is really cool.
How cool. And then we also have a good afternoon. So yeah, good afternoon to you too. So like we've said, it takes about 30,687 Earth days to complete one orbit around the sun. So that's a very long time. And Uranus happens to be made of water, methane, ammonia fluids, and it's also all of that above a rocky center. So methane is actually what makes this planet appear blue, a very light blue.
Very cool stuff. And, you know, it's just one of the really cool planets that we have. Uranus is an ice giant.
But no surface.
But with no surface. So now you did mention that there are some rocks within there.
It's rocky center.
Right, it's a rocky center, but it doesn't have necessarily a surface like what Earth does and like what Mars. And then once we get beyond Mars, remember, it's a lot of those gas giants like Jupiter and Saturn.
And so if people were on Uranus, we'd talk funny too, because helium is also what makes up its atmosphere, along with hydrogen and a small amount of methane. And like I said, that methane contributes to its appearance and why it appears with that lighter blue in our solar system.
So you also talk funny? Man, it must be hard for this planet to be taken seriously.
I think so, yeah. But you kind of have to take it seriously. I mean, wind speeds can reach up to 560 miles per hour. Wow. So that part I would take seriously.
Yeah, I would take that very seriously. 560 miles per hour. We talk about damaging winds within hurricanes when we talk about Tropical Tuesday. How damaging winds really like pick up at about, you can have catastrophic damage at about 95 plus miles per hour. So imagine 560 mile per hour winds. Whew. There is no standing. Yeah. There is no standing.
I guess that's one of the top speeds in all of our solar system as far as wind speeds go. You know, we've been talking about winds on Jupiter and how they got about, 400, 450 miles per hour, but 560 mile per hour wind speeds. I just couldn't even imagine that.
Yeah. And you wouldn't be able to stand up if there were surface.
Yeah, definitely.
I said stand up. Imagine standing up, but if there were surface, you imagine standing up.
So there's not been many spacecrafts in space that have flown by Uranus. The only spacecraft to fly by was Voyager 2. And there are 27 named moons, but their moons around Uranus have actually been named after characters from the works of William Shakespeare, which you've probably heard about in school. And Alexander Pope. Remember Romeo and Juliet from William Shakespeare? Yeah. There's actually a moon named Juliet, but not Romeo. I don't know why Romeo.
Romeo.
Yeah.
Art thou Romeo.
Yeah, sorry about it, Romeo. But there is a moon named after Juliet, so that's kind of cool there. Matthew also adds, I actually put a ring around Uranus in my drawing. That's awesome, Matthew. I can't wait to see that drawing. Camden wants to know if aliens are on the other planets. I know it has nothing to do with what you're talking about, but he won't leave me alone, LOL.
The answer, Camden, is not that I know of. So that's the best answer that I can give you. Not that we know of. But, you know, there's a lot of unknowns. When we talk about space, it's really interesting because we're finding out new things all the time about space.
Yeah.
So I will say not that we know of, but, you know, maybe we do find creatures on another planet one day. It's just right now we don't know that any are there. So right now, no to your question, but could be a yes someday. Who knows?
And, you know, technology, you know, going back to technology, it is getting better and better. So, you know, there are future missions that happen to observe the planet Uranus. Of course, there's only been one spacecraft to really fly by this planet. So I'm sure there's going to be many missions in the future, greater technologies. You know, it's really the gravity, the extreme temperatures, and the extreme pressures that, you know, science and technology really have to fight with in the solar system. So that's kind of the trickiest aspect when it comes to the solar system, because of course planet Earth is so much different, you know, compared to, let's say, Jupiter. It's a gas giant. You know, we've talked about Jupiter in the last talk and how you can't just simply fly through Jupiter, even though it is made of gas and high wind. It's because the extreme pressures, the extreme temperatures. I mean, I guess temperatures get so hot on some planets that it can even melt iron. So it would just smash the spacecraft.
Yeah, they've tried to land things on Venus before, and then it's so hot that melts, and you run into all these issues because things that work on our planet, we'll build them. We'll build these things on our planet, and then we'll try to send them somewhere else, and we try to prepare them the best we can to handle these other elements. But you can only prepare something so much when you're on this other planet trying to figure out how to get something there, and there's a lot of unknowns. So when the equipment gets to those planets, all of a sudden you'll find something out right away, and the equipment would fail. So there's a lot of things that they're trying to figure out there.
Yeah, definitely.
And that's something that the Voyager missions have worked to find out. They're trying, when they send something way out there, they're trying to find out more about these planets so that maybe one day we could send something to gather even more information.
There's a lot to study. Not only do you have the planet itself, you have what causes the features, the appearances, and the colors of each planet, the moons. You know, Uranus itself has 27 named moons. And so then you have the moons to study as well. So there are so many features of the solar system that spacecraft really have to study. And, you know, what those craters are from and why those colors appear the way they do. And chemistry is a big factor when it comes to the solar system, along with physics, and even have some weather. We talked about, you know, 560-mile-an-hour wind gusts. And we've also talked about, you know, the storms and the winds and the chemistry with methane and then nitrogen coming into play.
Yeah, and the periodic table. I mean, you think about that, all the things on the periodic table, and, you know, every once in a while, they'll find something new to add to the periodic table. Well, imagine there could be a lot more out there that we don't know about to add to the periodic table from these other planets.
So we were just taught the rings, and the planet Uranus has two sets of rings. Now, the inner rings closer to the planet are narrow and darker, but the outer rings around the planet actually appear more bright. So you can see them easier, kind of like the rings around the planet Saturn.
Wow, very cool.
Talked about how it rotates backwards and also on its side. Now let's get into Neptune. So now we're moving farther away from the sun. And Neptune is also very large. It's more than 30 times as far from the sun as Earth.
Wow.
Yeah, and Neptune is 4 times bigger than Earth.
Wow. So it's a lot bigger than Earth.
Yeah, it is a lot bigger than Earth. And also, you know, Earth is a lot closer to the sun. And so when you think about Neptune further away, the light we see on Earth is 900 times as bright as the sunlight on Neptune.
Wow. So it's a lot, it's not as sun, or it's not as bright there, I guess. And then also, you have to remember that it takes a lot longer for the light to get there. So it takes, I forget how long it takes for the sunlight from the sun to reach the Earth. Isn't it something like a little more than 10 minutes?
Something like that.
So you can only imagine
it
could take more than an hour for it to get to Neptune possibly then. So if that is the case, I may be wrong on that, guys. I'll have to go back and check that out. Again, we're talking about space here, so there's a lot of stuff to think about. But it could take more than it could take a really long time for sunlight to reach Neptune. But it doesn't take one day. It doesn't take too long for one day to occur on Neptune.
So the day on Neptune is a lot shorter than a day, at least by an hour, than a day on Uranus. So one day is equal to 16 hours, but of course it's an hour longer on the planet Uranus. And Neptune is also an ice giant, but it's mostly made of water, methane, and ammonia. So we talked about methane contributing to the color of the planet Uranus, but it also contributes to the appearance of Neptune. And that's why it has that blue cast as well.
Yeah, and these outer planets are always so beautiful with their vibrant colors. You think about Jupiter, and then we go into Saturn. And then we get all the bluish colors from Uranus and Neptune. Such beautiful planets. And Neptune also has a spot on it.
It does.
Yeah.
So it has kind of like that darker, I would say, bluish, purplish spot on the planet. And we'll actually talk more about that too. I'm starting to see a trend as well that the atmospheres with a lot of the planets in our solar system mainly consist of hydrogen, helium, and methane. At least both, the planet Uranus and also the planet Neptune. That's kind of a similarity there. I love that,
Enlightening.
Enlightening. I like the pun. So Neptune has at least 5 rings and 4 ring arcs. So believe it or not, Neptune also has rings around the planet. And when we talk about ring arcs, that just basically means just clumps of dust and also debris. So it's really kind of hard to see those rings.
Yeah, and Voyager 2 also made it all the way to Neptune as well as Uranus, and is the only spacecraft to have visited the planet up close.
And there are 14 known moons.
14, wow.
Around Neptune. So, I mean, think about our moon too. We only have 1 natural satellite. So having 14 known moons, just amazing. Yeah,
that's a lot.
So now we're getting into the last planet here. Now Pluto has had some difficulty over the years.
When I was a kid, I was always told Pluto is a planet. There was no question. When I was a kid, there was no question whether a planet or not. It was just always a planet.
Well, we talked about the sayings on how to memorize planets. My very excellent mother just served us 9 pizzas. That's what I've learned. But now we're saying my very excellent mother just served us nachos.
Nachos, man. Can we get nachos and pizza?
Yeah.
Can I just get both?
Yeah. Nachos, please.
Nacho pizza. But yeah, it's there is a little bit of a question on whether Pluto is a planet or not. It's now classed as a dwarf planet. So it is smaller than Earth's moon. That's the thing. It is a pretty small planet. So you can only imagine it's really hard to see it far away.
But kind of like Earth, it has mountains, it has valleys, and it has plains, and it could possibly have glaciers on Pluto because it gets so cold. And I've talked about how Venus is my favorite planet, but I'm starting to learn about Pluto, researching this for Cloudy with a Chance of Learning, and I found something so cool about this planet, and it's at the end of this show, and I just can't wait to share it with you.
When did Mickey's dog become a planet? Matthew, that's a good question. I think Pluto may have gotten his name after the planet. But yeah, that's a funny question there too.
And I also want to point this out from Pedro Lopez, Cloudy with a Chance of No Meatballs. That's awesome. Matthew's in a joking mood.
That's like that though. Yeah. Continue to leave the jokes. We like it. So thank you so much.
For sure.
Yeah, we like it. We love the positivity. So keep them coming, Matthew. We like it. During long-distance space travel, would astronauts require shielding from radiation? Robert, the answer is I'm fairly sure yes, and I'm sure we already have that on many of our spacecrafts. That's the reason why astronauts are able to go up to that International Space Station and still stay safe, even though they can be up there for more than 300 days. So I'm sure they've already worked that out, because there are these solar winds that we talk about that come off the sun whenever there's a large solar flare, and those solar winds can also attribute a lot of radiation. So yeah, hope that answers your question. We know about that stuff. Space weather and meteorology go a little bit hand in hand, but it starts to change a little bit when you get out into space. Some of the data, we talk about weather data all the time. If you look at a data table for space weather, it's a bunch of numbers. It looks pretty wild. I myself cannot read it. You'd have to study it for a while. I've looked at the tables and I just shook my head like I have no idea what I'm looking at. Just because that's data that's interpreted by people who study something kind of beyond meteorology. We study the atmosphere. That's a little bit further out.
Well, and we talked about Earth and how it has so many layers. Think of an onion, for example, has so many layers to our atmosphere. And with weather on planet Earth and then also weather on other planets, I think the atmosphere is also going to play a huge role. Not only that, but the distance from the sun, the orbit. We talked about the planets, not the planets, but the 4 seasons, and how, the Earth's tilt and the orbit around the sun contributes to our 4 seasons. So that's why the weather changes, dramatically across each planet.
Yeah. And Pluto, man, one day it takes a while.
Yeah, it really does.
153 hours for one day.
Yeah, and it spins on its side and also rotates backwards.
Wow, I didn't know it spun on its side. I actually did not know that about Pluto.
Yep, so it has a pretty big tilt on its axis.
Wow.
Yeah.
And it's known as, man, that is a wild word. What is that word, Megan?
Which one?
The Kuiper Belt?
The Kuiper Belt. So Pluto happens to be part of the Kuiper Belt, which kind of, goes back to the dwarf planet thing, because the Kuiper Belt is just filled with icy, rocky objects, kind of like Pluto. Pluto has crazy temperature extremes. Let's talk about, here's a review for you, the planet Venus. It has a thin atmosphere, and with a thin atmosphere, heat can actually escape easier. And so it could be as warm as 70 degrees one day on Venus and then drop to negative 225 degrees, so 225 below. Just crazy temperature swings, and that's all going back to the atmosphere. With a thin atmosphere, the planet can heat up quicker, and also heat can be released faster. 70
degrees sounds great, but negative 225, no thank you. I will pass on that.
Yeah, so that kind of goes back to, the crazy weather extremes. So this is also pretty interesting. Think of the United States. Pluto is only half the width of the United States.
Oh, wow.
So it is a very small planet.
Wow.
Pluto has an oval-shaped path around the sun, so it orbits the sun kind of in this oval shape, whereas most planets are kind of like a perfect circle when you look at their orbit compared to Pluto. So it's more of an oval around the sun. The lowest temperature on the planet, 140 degrees below zero.
Too cold.
Too cold.
And mountains made of water and ice on Pluto can reach heights of 6,500 feet to 9,800 feet. Wow.
So it also has mountains. There are valleys, like we talked about, and plains on the planet Pluto.
Wow. Camden thinks we were born at the moon and then came down here on Earth. That is Camden. That is a wild theory.
That is a wild theory.
The moon sure is pretty to look at. That's all I know.
Yeah. It can just light up our sky too. It did the other night when we had that full moon. I mean, just so bright in our sky.
Yeah.
So let's talk about Pluto's atmosphere. It also has a thin atmosphere that will expand when it comes closer to the sun.
Wow. Oh, so, you know, we talk about high pressure and when things can warm up and it can cause expanding of the air. So I guess that's kind of similar to how our atmosphere works.
Kind of like lightning and thunder.
Oh.
Rapid expansion of air, right? That's what thunder is.
Interesting.
And then the atmosphere around Pluto consists of nitrogen, carbon monoxide, and methane. And when Pluto approaches the sun, the surface will sublimate. So here's a question for you. I actually wanted to pause on sublimate because sublimate happens to be a part of the water cycle. We have evaporation, condensation, and precipitation. Those are the main three, right? In getting a thunderstorm, for example. Do you want to talk about the water cycle a little bit with evaporation, condensation?
Yeah, so we have whenever let's say the sun hits the surface of Canyon Lake or the Gulf of Mexico.
Yeah.
That sunlight or the heat will cause the water to possibly start to evaporate. As the water evaporates, it will actually cool and condense. Evaporation is a cooling process. We have a dry day outside and we're sweating, but you're not seeing the sweat on your skin. It's like evaporating immediately. It won't be as bad as if the temperature is the same temperature, but the humidity is higher. If the same temperature is the same, but we have higher humidity and it's real humid outside, the sweat will beat up on your skin. And honestly, it will feel so much hotter because condensing is a heating process. Now, if that moisture is evaporating off your skin, this is kind of in depth. So stick with me as much as you can, guys. All right. If the moisture is evaporating off your skin, you are cooling off. If the moisture is condensing on your skin and you're sweating,
you're warming up.
You're warming up, or at least the evaporation is slower, so you're not feeling as cool as what you could be if the air were drier outside. So that's a little bit of an advanced lesson condensed into a quick explanation. But you'll have evaporating water, and then it will condense, form clouds, then it rains, and then the cycle starts all over. It goes into the streams, back into the Gulf, evaporation, and then you have it happen all over again.
And so with the water cycle, we're talking about going from a solid to a liquid, which is melting, right?
Right.
And then liquid to a gas,
which is evaporation.
And then, so now we're going to talk about sublimation, which is kind of a part of that water cycle, right? Do you want to dive into sublimation?
Yeah, it's how you can transfer from one to another, not in the way that we typically do it. Yeah, so it's in a bit of a different process.
Yeah, so what do you think sublimation is? Is it going from a solid to a gas or a gas to a solid? So think about that a little bit. And if you think you know, comment below on our Facebook Live and we'll let you know if the answer is right. So the reason why we're talking about sublimation on Pluto, and I know that's a big word, is because it is a very cool thing about the dwarf planet. So when Pluto approaches the sun, the surface will sublimate. So let's advance it here. So sublimation happens when you go from a solid to a gas. The gas will then rise to form an atmosphere around Pluto. That is crazy.
That is wild.
That is the biggest difference from our planet Earth and Pluto, is just because the gas will then rise to form an atmosphere around Pluto. So we know that sublimation happens when you go from a solid to a gas.
So imagine if you just went straight from ice to water vapor. Pretty much. Exactly.
And so you have that vapor, that gas, right, that will rise to form the atmosphere around Pluto. And this all happens when Pluto starts to get closer and closer to the sun on its oval-shaped orbit.
Wow.
So that's pretty impressive there. And we've learned what sublimation means.
Yeah.
So we've kind of skipped a step. Rather than going from solid, liquid, gas, we skip liquid altogether and just go from a solid to a gas.
Yeah.
Pretty crazy.
Pretty cool stuff.
So now Pluto will get much colder as it moves away from the sun. So think about it this way, you know, the temperature just falls slowly as it moves away from the sun because it doesn't have the sun heating up the planet as much. Here's the cool weather part of Pluto. So the atmosphere around Pluto will freeze.
Wow.
So we talked about that gas rising. And then as Pluto moves away from the sun, the atmosphere around Pluto will freeze and then fall as snow to the surface.
Wow. So a lot of snow on the planet Pluto then.
Yeah.
But I'm sure it has more stuff than just water in it, huh?
Oh, yeah, definitely. Because we talked about methane and also carbon monoxide.
So not as fun snow as what we have here on Earth.
Yeah. So, yeah, this is the crazy, you know, water cycle part of it. So there actually is some weather that occurs on the dwarf planet Pluto. So remember, as Pluto, it gets much colder as it moves away from the sun. So don't overthink that part. That part's pretty easy. You know, you're moving away from your heat source. So you're getting a little bit colder. And then that gas will then freeze and then fall as snow to the surface.
Yeah.
And so that's going to wrap up our solar system.
Yeah, and guys, you know, we're going to talk more about this next week. We're going to talk more about some of the other things out there like comets and the asteroid belt. Tomorrow is Tropical Tuesday. We're going to talk a little bit more about storm surge and how storm surge can go up rivers and into lakes and how it can impact areas beyond the coast, even you know, the direct coast, still coastal areas, but further inland even. I want to talk a little bit about that cone of uncertainty that we always talk about, the forecast cone for hurricanes and tropical systems.
And the cone changes throughout the year. So it's something that's pretty interesting because, you know, the National Hurricane Center and all these scientists and researchers will come up with a plan on how to make the cone better over the years. So now that it's 2020, there's going to be new research done, and the cone of uncertainty will change. So we'll dive into that tomorrow. Yeah,
always advancing. As a scientist, this is the most important thing to know. When you're a scientist, you should always be learning and advancing. You should never be set with how you are and how things are working. There's always a next step. That's the beauty of science, but also something that has been a challenge for scientists throughout the years. I mean, you're trying to get to the highest point that you can and you pretty pass the torch and say, okay, next generation, here's everything we know. Try to find out more from this. And so we're trying to build off of what people have been for years and years and years and trying to advance it. And there's always more to learn and more to do. That's the beauty of science.
Yeah, and there's going to be a lot to talk about with Tropical Tuesday, and this is going to apply to a lot of you, especially when it comes to hurricane season. It's less than a month away. Technically, we're kind of already in hurricane season because it's not rare for things to form out into open right now as we start warming up over the oceans. Wednesday, we're going to cover Computer Models 101. There are so many interesting things that we look at. There are different charts. You know, as meteorologists, we not only look at surface analysis, we go above and beyond. We look at 250 millibar maps. 300.
Way up high in the atmosphere.
So high in the atmosphere. So that's when we talk about dreams. You know, 250, 300 millibars. We look at 500 millibars.
That's a very that is where we really start to see little things called short waves and things like that, which actually impact our weather here at the surface.
And actually, we show 500, this kind of a teaser here, but we show 500 millibar maps on our daily forecast sometimes on KINS 5.
Yeah, those upper level patterns.
750 millibars, 850 millibars, and then, of course, we're starting to get toward the surface. So a lot of cool things there. That's how we look at cold fronts and warm fronts, and that helps us with computer models and also forecasting. Thursday, how heat affects the body. You kind of got into that a little bit with the water cycle and how condensation, evaporation.
That evaporation, the condensation, moisture in the air can lead to condensation on your body. And it'll make it feel hotter, but if you have evaporation, it cools off. We're going to talk more about that on Thursday.
And then Fun Time Friday, you know, you were just talking about how Matthew, he drew this awesome picture of the solar system. And Matthew, you were just talking about drawing the rings around the planet Uranus. Hey, share your pictures with us. If you find an interesting topic or you want us to talk about a topic next, share it with me, Andrew, Bill Taylor. You can email us. I'm Massey@kins5.com. You're A. Wilson at kins5.com, and then B. Taylor at kins5.com. So,
yeah, we love to share them, and we shared Matthew's photo on Friday.
Yeah.
And Matthew, I want to be sure I show it to Megan. That way she gets to see it too.
I can't wait.
Yep. Well, guys, we hope you have a wonderful rest of your day. We're going to be on at 4 o'clock for Kins 5. That's going to be on, of course, the CBS affiliate here in San Antonio. Be sure to tune in 4, 5, 6, and 10 with all the latest news and weather. Weather Chief Bill Taylor, of course, is going to be in this afternoon. We hope you all have a wonderful day, and we'll see you again right here tomorrow at 1 p.m. for Cloudy with a Chance of Learning.
And by the way, Paula Neal says thank you both for your interesting information. You're welcome, Paula. Join us tomorrow for Tropical Tuesday. We'll be live, like Andrew's been saying, on Facebook and YouTube at 1 p.m. And we'll see you tomorrow.
Yeah, have a great one.